This is Spacetime Series 22, Episode 51. Coming up on Spacetime. First images of the origins of single fast radio bursts. It's all systems go for a new spacecraft to study the Sun. And the discovery of dust rings around Venus could provide new clues to uncharted asteroids. All that and more coming up on Spacetime.
Welcome to Spacetime with Stuart Gary.
Astronomers have for the first time ever imaged the exact location of a one-off fast radio burst, one of the most mysterious events in the universe. The blast, designated FRB 180924, originated about 13,000 light-years out from the centre of a spiral galaxy similar in size to the Milky Way, known as DESJ 214425.25 minus 405.400.81, located in the southern skies about 3.6 billion light-years away. The findings, reported in the journal Science, will help astronomers trying to understand the origins of these powerful yet ephemeral cosmic blasts. Fast radio bursts suddenly blast across the universe, but only last a second, making it extremely difficult to determine what they are and where they come from. The study's lead author, Dr. Keith Bannister from the CSIRO, says this discovery is the big breakthrough the field's been waiting for since astronomers first discovered fast radio bursts in 2007. In the 12 years since, the global hunt has so far netted about 85 of these events. Most have been one-off single bursts, but a tiny fraction are repeaters that reoccur at the same location over and over again. In 2017, astronomers found a repeater's home galaxy, but localizing one-off bursts is far more challenging. And that's where this new discovery comes in. It was made using ASCAP, the CSIRO's new Australia Square Kilometre Array Pathfinder radio telescope in Western Australia. Bannister's team developed new technology to freeze and save ASCAP data less than a second after it arrived at the telescope. And it's this new technology which was used to pinpoint the exact location of the fast radio burst, not just to its home galaxy, but to which part of the home galaxy it originated from. ASCAP's an array of 36 independent 12-metre dish antennas spread over a 6-kilometre area of the Murchison Radio Astronomy Observatory. Because the dishes are all spread apart, the blast of energy from the fast radio burst had to travel slightly different distances and therefore reached each of the antennas at slightly different times. It was from these tiny time differentiations, just a fraction of a billionth of a second, that the authors were able to identify the burst's home galaxy and even its exact starting point. The galaxy from which the burst originated was then targeted by the world's 3 largest optical telescopes. It was imaged with one of the European Southern Observatory's 4-metre VLT, or Very Large Telescopes, in Chile, and its distance was measured with one of the giant twin 10-metre Keck telescopes in Hawaii and the 8.1-metre Gemini South Telescope, also in Chile. As well as trying to find out what fast radio bursts are, astronomers want to use them to study the space they're travelling through, from their origins to the time they're picked up at the radio telescope. That's because these bursts are being altered by the matter they encounter during their journey through space. Now that scientists can pinpoint where they come from, they can use them to measure the amount of matter in intergalactic space, and this will reveal material that astronomers have been struggling for decades to try and locate. The only previously located fast radio burst, the repeater, originated in a very tiny galaxy that's forming lots of new stars. But the host galaxy for this new burst looks nothing like that. It's a massive galaxy forming relatively few stars, and this suggests that fast radio bursts can either be produced by a variety of environments, or that the seemingly one-off bursts detected so far by ASCAP are generated by a different mechanism to the repeater. Bannister says the cause of fast radio bursts remains unknown, but the ability to determine their exact location is a big leap towards solving that mystery. And this is Spacetime. I'm Stuart Gary. The European Space Agency's Solar Orbiter is continuing with a long series of tests as mission managers prepare the 1.8-tonne spacecraft for its 7-year mission to study the Sun. Solar Orbiter will launch in February aboard an Atlas V rocket from the Cape Canaveral Air Force Station in Florida. It'll use multiple gravity-assist flybys of Venus and the Earth over 3.5 years to reach an eccentric, highly elongated 150 Earth-day orbit around the Sun, with a perigee, or nearest orbital position, just 46 million kilometres from the Sun. That's well inside the orbit of Mercury. At that distance, Solar Orbiter will be soaked in constant temperatures of over 500 degrees Celsius. The mission will try to discover how the Sun creates and controls the heliosphere. The probe will undertake detailed measurements of the inner heliosphere and nascent solar wind and perform close-up observations of the Sun's polar regions, which are impossible to do from Earth. During each of its 5-month orbits around the Sun, the spacecraft will watch magnetic field activity build up in the Sun's corona. These can lead to powerful eruptions, solar flares, and coronal mass ejections. To carry out its mission, the spacecraft carries a suite of 10 scientific instruments to observe the turbulent, sometimes violent surface of the Sun and study the changes taking place in the solar wind. These include a solar wind analyzer to measure solar wind properties and composition, an energetic particle detector to study suprathermal ions, electrons, and neutral atoms, as well as energetic particles ranging from just a few kilo-electron-volts up to relativistic electrons and ions, with protons of up to 100 megaelectron-volts and ions of up to 200 megaelectron-volts. Also aboard is a magnetometer to provide detailed measurements of the Sun's magnetic field, a polarimetric and helioseismic imager to provide high-resolution and full disk measurements of the photospheric magnetic field. There's a sun and high-resolution imager to take shots of different layers of the solar atmosphere, a spectral imager to undertake spectral images of the solar disk and corona in order to characterize plasma properties on the Sun, a spectrometer telescope for studying the composition of thermal and non-thermal solar X-ray emissions between 4 and 150 kilo-electron-volts, a chronograph to provide simultaneous ultraviolet and polarized visible light imaging of the corona, and a heliospheric imager to study the solar wind. ESA TV Sue Nelson reports the spacecraft is now undergoing vibration, acoustic and shock tests before being sent to the United States for launch.
At the IABG National Space Center near Munich in Germany, the Solar Orbiter spacecraft undergoes crucial tests for its mission to observe our nearest star. The Sun is an essential part of our solar system, providing the Earth with heat, light, and life. But before Solar Orbiter gets to study the Sun's features, activity, solar wind, electric and magnetic fields, engineers must be certain it can withstand the stresses of launch.
And here to tell me a little bit more about it is Cesar Garcia, who's the project manager for Solar Orbiter for ESA. Cesar, first of all, could you begin by explaining what is Solar Orbiter?
Well, Solar Orbiter is a science mission that will get close to the Sun to take crucial measurements and trying to find out how the heliosphere of the Sun is operating and is working. And to do that, it carries a series of instruments, actually 10 instruments. Some of them will be taking in situ measurements. They will be taken in particles as they come out of the Sun before they get further away, and then they get all mixed up in turbulence. And at the same time, it will be taking remote images and spectrographs of the Sun surface, of the Sun corona, and of the Sun heliosphere to try to correlate what happens in those areas of the Sun with the particles which are also collected.
It'd be quite good to explain why we're both wearing these hats and the bunny suits and the protective covering.
Okay, we have to be crucially careful with the contamination that gets close to the instruments of Solar Orbiter because they are very sensitive to that contamination. There are two kinds of contamination. There are particles and there is molecular contamination as well, which one could explain as the smell coming out of new materials. All these both types of contaminations, if they can confuse the sensors when they take the measurements or actually block the cameras or the telescopes of the sensors. So we have to make sure that everything is extremely clean near Solar Orbiter.
What type of tests are going on in here at the moment?
What we are doing now is what we call vibration tests. We want to expose the spacecraft to the conditions similar to what the spacecraft will see when it goes up on top of the rocket. What we are doing now is what we call the sign test, and the sign test is exciting the spacecraft, mechanically moving the spacecraft either 5 times per second and slowly going up until 100 times per second. And we do that to make sure that the spacecraft will not break once it goes on top of the rocket away from the Earth. What we do in these vibration tests, we put them on a table which is very well lubricated with oil, and we use some what we call voice coil actuators, which is basically very powerful loudspeakers, and we do a vibrational movement of the spacecraft longitudinally and then laterally, and what we try to see is the resonant frequencies of the spacecraft. The spacecraft behaves like a bell, and then once you hit on the bell, then it sounds on its natural frequency. So what we're now trying to measure is what are the natural frequencies of the spacecraft, and then in some cases that when we are exciting the spacecraft at those natural frequencies, that nothing breaks loose.
Once the vibration tests are over, what are the next tests that are going to be happening between now and the launch?
Well, following the sign vibration test, we will put the spacecraft in a chamber with thick walls where we will subject it to an acoustic test, which is basically having a very, very loud acoustic noise around the spacecraft. Following that, we will take it into another special chamber with spiky walls and a very absorbent material, and there we will do a test of magnetic compatibility, electromagnetic compatibility. And finally, we will take it to a wooden building where we will measure the magnetic signature of the spacecraft itself, as some of our instruments are extremely sensitive to magnetic fields, and we want to make sure that the instruments will not be measuring the spacecraft itself.
So quite a few tests before launch, and then it will launch from NASA.
It will launch from the Kennedy Space Center. A solar orbiter is a collaboration mission between ESA and NASA, and the main NASA contribution is twofold. It's one of the 10 instruments, and the second contribution is the launcher services, the rocket and all the antennas and all the infrastructure around the launch event.
An international collaboration, the spacecraft was built and is being tested by Airbus. After the vibration tests, which can shake the craft up to 120 times per second, are the higher frequency acoustic tests, then shock tests for when the spacecraft deploys its solar arrays, antennas or instrument boom. The high-gain antenna, used to receive telecommands and send data and images back to Earth, will use just 1 kilowatt of power, much less than a dishwasher, and the heat shields at the top of the spacecraft, which required specially made blankets, will protect the normal operating temperature of 30 degrees Celsius inside from much hotter conditions outside.
We're in an orbit which is about 160 days long. We go very close to the Sun, about 42 million kilometres from the Sun. It doesn't sound close, but it's actually much closer than we are from the Earth. And at that distance, we will see power from the Sun about 12 to 13 times hotter than what we see here on Earth. That means the temperatures get very hot, over 500 degrees centigrade. But because we're in this long elliptical orbit, we'll also go out really quite far away from the Sun, so we'll actually get very cold as well. So we'll see this thermal cycling. Every 160 days we'll go hot and cold and hot and cold. And we do about 20 of those orbits for the complete mission of Solar Orbiter.
Solar Orbiter will also be up to 180 million kilometres away from the Sun. This allows it to make both in situ and remote measurements at different distances with some of its 10 instruments. To keep these instruments clean and to protect them from humidity, dry nitrogen gas is pumped through them 24 hours a day, process that will happen all the way up to the Atlas V launch vehicle liftoff. The joint ESA and NASA mission will launch from Cape Canaveral in early 2020, and these next few months are vital to ensure that Solar Orbiter is ready for the spotlight.
And that report by ESA TV's Sue Nelson, speaking with ESA's Solar Orbiter Project Manager Cesar Garcia and Ian Walters, the Solar Orbiter Project Manager with Airbus Defence and Space. And you're listening to Spacetime. I'm Stuart Gary. Astronomers studying dust rings in the inner solar system, tracing the orbits of Mercury, Venus and Earth, believe the Venusian ring could hint at uncharted asteroids. Just as dust gathers in corners and along bookshelves in houses, dust also piles up in space. And when dust settles in the solar system, it's often in rings. There are several dust rings which circle the Sun. The rings trace the orbits of planets, whose gravity tugs the dust into place around the Sun as it drifts by on its way to the centre of the solar system. This dust consists of crushed-up remains from the formation of the solar system some 4.6 billion years ago. A lot of it is rubble from asteroid collisions, or crumbs from blazing comets. This dust is dispersed throughout the entire solar system, but it collects in these grainy rings overlying the orbits of Earth and Venus, and these rings can be seen with telescopes on Earth. By studying this dust, what it's made of and where it comes from, as well as how it moves through space, scientists seek clues to understanding the birth of planets and the composition of everything we see in the solar system. Now, 2 new studies have reported new discoveries about dust rings in the inner solar system. One study, reported in the Astrophysical Journal, uses NASA data to outline evidence for a ring around the Sun at Mercury's orbit. A second study, reported in the Astrophysical Journal Letters, looks at the likely source of another dust ring, this one at Venus's orbit, and suggests that it originates from a group of never-before-detected asteroids co-orbiting with the planet. The authors describe evidence for a fine haze of cosmic dust over Mercury's orbit, forming a ring some 4,900 kilometres wide, just big enough for Australia or the continental United States to stretch across. Mercury wades through this vast dust trail as it circles the Sun. Ironically, scientists stumbled across this ring while they were searching for evidence of a dust-free region close to the Sun. See, at some distance from the Sun, according to a decades-old prediction, the star's mighty heat should vaporize dust, sweeping clean an entire stretch of space. Knowing where this dust is might tell scientists something about the composition of the dust itself, and may also hint at how planets formed in the young solar system. So far, no evidence has been found of dust-free space, but that could be partly because it would be difficult to detect from Earth. No matter how scientists look from Earth, the fact is all the dust between us and the Sun gets in the way, tricking scientists into thinking that perhaps the space near the Sun's a lot dustier than it really is. The authors figured they could work around the problem by building a model based on images of interplanetary space from NASA's Solar and Terrestrial Relations Observatory, or STEREO spacecraft. You see, the scientists wanted to test their new model in preparation for NASA's now-launched Parker Solar Probe, which is currently flying a highly elliptical orbit around the Sun and swinging closer and closer to the star over the next 7 years. Researchers wanted to apply their technique to the images Parker will send back to Earth to see how dust near the Sun behaves. Scientists have never worked with data collected from this unexplored territory so close to the Sun. So the models would provide a crucial context for understanding the Parker Solar Probe's observations, as well as hinting as to what sort of space environment the probe will find ahead of itself. Will it be sooty, or will it be sparkling clean? 2 kinds of light show up in the STEREO spacecraft images. Firstly, there's the light from the Sun's blazing outer atmosphere, the corona. And then there's light reflected off all the dust particles floating through space. And the sunlight being reflected off all this dust is about 100 times brighter than the coronal light. Scientists who study solar activity to forecast imminent space weather, including giant explosions of solar material such as solar flares or coronal mass ejections, which the Sun can sometimes send in our direction, have spent years developing techniques to remove the effect of this dust. Only after removing light contamination from the dust can they clearly see what the corona is doing. The authors built their model as a tool to get rid of all the pesky dust in STEREO and the Parker Solar Probe images. But the prediction of dust-free space has lingered in the back of their minds. If they could devise a way of separating the 2 kinds of light and isolating the dust shine, they might be able to figure out how much dust was really there. Finding out that all the light in an image came from the corona alone could indicate they finally found some dust-free space. Mercury's dust ring was a lucky find, a side discovery made while working on their model. When they used their new techniques on the STEREO images, they noticed a pattern of enhanced brightness along Mercury's orbit, more dust that is, in the light they'd otherwise planned to discard. They found that all around the Sun, regardless of the spacecraft's position, scientists found the same 5% increase in dust brightness or density. That said, something was there, and that something extends all the way around the Sun. Scientists had never considered that a ring might extend along Mercury's orbit, which may be why it's gone undetected until now. People had thought that Mercury, unlike Venus or the Earth, is simply too small and too close to the Sun to capture a dust ring. They figured that the solar wind and the magnetic forces from the Sun would blow away any excess dust at Mercury's orbit. Mind you, it's not the first time scientists had found a dust ring in the inner solar system. 25 years ago, scientists discovered that Earth orbits the Sun within a giant dust ring as well, and others had uncovered a similar ring near Venus's orbit, first using archival data from the German-American Helios space probes in 2007, and then confirming it in 2013 with data from the STEREO spacecraft. Since then, scientists determined that the ring in Earth's orbit comes largely from the asteroid belt, that vast donut-shaped region between Mars and Jupiter where most of the solar system's asteroids inhabit. Main-belt asteroids are constantly crashing into one another, in the process releasing clouds of particles, grains and dust. And all that stuff drifts deeper into the Sun's gravity, unless Earth's gravity pulls that dust aside into our planet's orbit. Because Venus is virtually the same size as the Earth, at first it seemed likely that Venus's dust ring formed like the Earth's, from dust produced elsewhere in the solar system. But when scientists modelled the dust spiralling towards the Sun from the asteroid belt, they produced a ring that matched the observations of Earth's ring, but not Venus's. After a series of simulations, scientists hypothesized that the Venusian dust must come from a never-before-detected bunch of asteroids which are orbiting the Sun alongside Venus. Viewed with the right tools, these asteroids could unlock new clues about the chemical diversity of our solar system. Because it's dispersed over a larger orbit, Venus's dust ring is much larger than the newly detected ring at Mercury's orbit. There's about 26 million kilometres from the top to the bottom of the Venusian ring, and the ring itself is about 10 million kilometres wide. It's about 10% denser with dust than surrounding space. Still, relatively speaking, it is very diffuse. The ring is littered with dust whose largest grains are roughly the size of those in coarse sandpaper. Using a dozen different modelling tools to simulate how dust moves around the solar system, the authors modelled all the different dust sources they could think of, looking for a simulated Venusian ring that matched their observations. The list of all possible sources included the main asteroid belt, the Oort cloud, as well as Oort cloud comets, Halley-type comets, Jupiter family comets, and recent collisions within the asteroid belt. Trouble is, none of them worked. Instead, they found the source of the dust most likely came from asteroids much closer to Venus than the main asteroid belt. So, what does all that mean? Well, there could be a group of asteroids co-orbiting the Sun with Venus, meaning they share Venus's orbit, sort of like Trojans, but still remain a long way from the planet, maybe even on the other side of the Sun from Venus. A group of asteroids in Venus's orbit could have gone undetected until now, because it's really difficult to point Earthbound telescopes in that direction, so close to the Sun, with all that glare of light interference from the Sun. Co-orbiting asteroids wouldn't be rare. In fact, co-orbiting asteroids are a great example of what's called a resonance, an orbital pattern that locks different asteroids together depending on how their gravitational influences meet. After modelling a range of different orbital resonances, from 2 to 3, 5 to 7, and so on, the authors found the best fit was a straightforward 1-to-1 resonance. That is, a bunch of asteroids matching Venus's orbit around the Sun 1 for 1. The authors then needed to show that the very existence of these asteroids would make sense in the solar system. So they built another model, this one starting with a throng of 10,000 asteroids neighbouring Venus. They then let the simulation fast forward through some 4.5 billion years of solar system history, incorporating all the gravitational effects from each of the planets. When the model reached the present day, about 800 of their test asteroids had survived the test of time. Now, it's only a crude simulation, but it demonstrated that asteroids could have formed near Venus in the chaos of the early solar system, and some could still remain there today, feeding the dust ring nearby. Of course, the next step will be actually hunting and finding these elusive asteroids. This is Spacetime. I'm Stuart Gary. 3 members of the Expedition 59 crew have returned safely to Earth after spending 6 months aboard the International Space Station. The trio undocked their Soyuz MS-11 capsule from the orbiting outpost Poisk module 2.5 hours before beginning their deorbit burn, designed to slow them down and allow them to re-enter Earth's atmosphere. Touchdown occurred 52 minutes later on the Kazakhstan steppe.
Soyuz and the station flying just over eastern Mongolia, departing from the Poisk module, the vehicle slowly backing away at an initial rate of just about 1/10 of a meter per second. It was propelled away by springs, actually, in the docking module that it was attached to. And then following that successful backway, they executed a departure burn, just a quick 8-second firing of engines on the Soyuz, just ramping things up by about 1/2 meter per second to begin backing away even faster. That happened when it was just about 15 meters, or just about 45 feet away from the International Space Station. But everything went smoothly with the departure. The Soyuz, at this point, several kilometers away from the space station, and pretty soon it's going to be setting up for the actual deorbit burn, which will be our next big milestone in tonight's journey, and that's going to be what actually sets the Soyuz spacecraft up to come home. But again, a successful undocking earlier today, setting the stage for our landing, and now we are just a few tasks away until the spacecraft is beginning to make its way through the Earth's atmosphere. And so at this point, they've passed entry interface. The vehicle now less than 100 kilometers over the Earth's surface. And so with that confirmation that entry interface has started, next they'll be moving into a plasma stage where the entry guidance will actually begin, but a plasma will begin to form around the vehicle that also can start to preclude us getting some of those audio communications with the crew, but they're scheduled to be in that plasma stage for about 5 minutes. And then following that, they'll be just about free and clear to open up the parachutes. Again, the heat shield on the bottom of the spacecraft oriented to protect the crew from all of the heating effects of this re-entry until eventually the parachutes get commanded to open, that coming at about, or just about 6.7 miles in height. Confirmation of the chute command being given at just 33 minutes after the hour. The Soyuz spacecraft, some white smoke coming out that's actually excess hydrogen peroxide being vented from on board the spacecraft. The Soyuz continuing to descend. Again, this main parachute's going to slow it down all the way to just 16 miles an hour, about 7.2 meters per second. At first, it's angled at about 30 degrees to just help expel any excess heat, but then shifting down to a straight vertical descent. It's going to continue to descend, hopefully aim to have the capsule land upright, but not unusual for it to roll over on its side. A light breeze in the area today, just a few mile-an-hour wind reported, so hopefully not too much pulling on the chute once it's down on the ground. Everything continuing to go smoothly, though, looking at that landing coming up in just about 10 minutes.
Barometric pressure 2330.
The Soyuz spacecraft under the main parachute continuing to descend down there in Kazakhstan. A couple of helicopters pass by in the background. We'll see several of them move in, but search and recovery forces from the Roscosmos, NASA, and Canadian Space Agency teams once this capsule is on the ground. Puff of smoke, that means the soft landing engines have fired and the capsule is on the ground. We're going to call this landing at 9:47 p.m. Central Time, 10:47 p.m. Eastern Time, down just to the southeast of Zhezkazgan, Kazakhstan. Oleg Kononenko, David St. Jacques, and McLean back on planet Earth.
During their time in orbit, the crew carried out 4 spacewalks and performed several hundred experiments. The space station's 3 remaining crew members are now beginning Expedition 60. They'll remain on station until October and then return to Earth aboard their own Soyuz MS-12 capsule. But before all that happens, they'll be joined by 3 new crew members on July the 20th when the Soyuz MS-13 blasts off from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. Well, for years you've been told to cut out your saturated fat intake and instead replace it with unsaturated fats in order to stay healthy. But now a group of experts are challenging that advice. A report in the British Medical Journal claims the advice, which is part of the World Health Organization's draft dietary guidelines, fails to take into account the evidence that the health effects of saturated fats vary depending on the specific fatty acid and the specific food source. The authors warn that these recommendations might cause a reduction in the intake of nutrient-dense foods that are important for preventing disease and improving health. A new study says Australia has recorded its lowest number of HIV diagnoses since 2001. The findings are contained in the latest report from the Kirby Institute at the University of New South Wales. Last year, there were 835 cases of HIV, the human immunodeficiency virus which causes AIDS, diagnosed across the country, and this represents a decline of 23% over 5 years. However, the news isn't all good. The drop was mainly among gay and bisexual men, with no similar decrease among heterosexuals or the indigenous population. There's a major environmental disaster in northern Australia, with massive mangrove diebacks occurring along the Gulf of Carpentaria, which have now released significant amounts of the potent greenhouse gas methane. Huge swathes of mangrove forest have died along a 1,000-kilometre stretch of the coastline. A report in the journal New Phytologist has found that more than 7,000 hectares of coastal mangroves have been lost, some 9% of mangrove vegetation stretching from just south of the Roper River in the Northern Territory to near Corumba in Queensland. James Cook University's Dr. Norman Duke says the dieback is unprecedented, and it followed a prolonged period of high temperatures and unseasonably dry conditions in the region. Meanwhile, researchers from the Southern Cross University found that dead trees had released significant amounts of the potent greenhouse gas methane. Iran has confirmed that it's now producing more enriched uranium than it's allowed to under its 2015 nuclear deal. The deal limits Tehran's enriched uranium stockpile to 300 kilograms. It's designed to prevent the Islamic Republic from having enough enriched uranium to develop nuclear weapons, or the missiles to deliver those atomic bombs against people it considers its enemies. Iran's already violated the deal by continuing to develop and test medium and long-range missiles, euphemistically describing them as orbital scientific missions. It's also continued funding terrorist organizations, including Hamas, Hezbollah, and Islamic Jihad. Then in 2018, Israel exposed Iran's nuclear archive, providing smuggled files, documents, photos and videos, confirming that the Islamic Republic was actively working towards the manufacture and testing of nuclear weapons. Included in the archive were the exact street address locations of secret Islamic Revolutionary Guard nuclear weapons research facilities and covert material storage locations. The oil-rich nation's always insisted its nuclear program is for peaceful power generation only. In May 2018, the White House pulled out of the Iran nuclear deal and reimposed economic sanctions because of what it describes as ongoing and flagrant violations. Iran's now responded to that by using Islamic Revolutionary Guard patrol boats to attach limpet mines on the sides of oil tankers in the Straits of Hormuz, detonating at least 4 of them and badly damaging the vessels. Last month, Tehran insisted it was not planning to scrap its nuclear deal, but it's now admitted that it is exceeding its agreed-to uranium enrichment limits. France has responded, warning Iran against carrying out any further measures that would put its nuclear deal into question. French President Emmanuel Macron says France would take steps to ensure Iran met its obligations. And now the British Royal Marines have boarded and seized an oil tanker believed to be carrying Iranian crude oil to Syria in breach of European sanctions. New research has confirmed what vegans, well, really everyone's already known, namely, salads don't scream when you eat them. A report in the journal Trends in Plant Science has reconfirmed that plants do not feel pain or loneliness. The review article's research states that only vertebrates, arthropods and cephalopods possess the brain structure for consciousness. And if there are animals that don't have consciousness, then brainless, neuronless plants don't have it either. So, vegetarians and vegans everywhere can breathe a sigh of relief. Some of our more senior listeners will probably remember the BlackBerry. It was the serious cell phone to have for successful business people, and for many it was the forerunner of today's smartphones. Well, the BlackBerry is back in an updated form. With all the details, we're joined by Alex Horosh from whistleout.com.
So the BlackBerry K2 is a newish BlackBerry smartphone. It actually came out in the middle of last year internationally, but it's finally made its way to Australia. So BlackBerry smartphones are now manufactured by TCL, who you might know from TVs, but they also own Alcatel, who's, I guess, a value-driven smartphone manufacturer. So the K2 is powered by Android like most smartphones on the market, but it still has that traditional BlackBerry keyboard.
Yeah, that was what made BlackBerries famous.
Yeah, that's correct. Almost 24 years ago now, I guess BlackBerry's heyday was really like the early 2000s. I guess like the thing with the K2 is you really have to want a physical keyboard. I mean, like I'm, I guess, a touchscreen native. My first smartphones all had touchscreens. Some had styluses, but I kind of grew up in that era of touch, so I just can't get my head around a BlackBerry keyboard. Like, there's so many like little kind of quirks, like modifier keys if you want to get symbols, and you just have to. It's almost like relearning how to drive. And I just did some basic speed tests between the BlackBerry keyboard and my iPhone, and I found I could type almost 4 times faster on my iPhone, even ignoring like punctuation. At the same time, like there is something really nice about the K2's keyboard. It just has a really satisfying tactility to it. Like it does feel nice to click, and you can kind of understand why people were so in love with the BlackBerry brand.
Is this a phone that is primarily targeting the older generations, those who used BlackBerries during their heyday, or is this something which would appeal to, well, someone like yourself?
As much as I think BlackBerry would love it to appeal to iPhone and Android users, I think this is really one for the fans. You have to love BlackBerry to want this phone. It's quite expensive. It's almost $1,200. It's all about the keyboard, and you really are paying for the keyboard, and that's kind of what sets it apart from every other phone on the market.
Sounds like comfort food.
Exactly. That's a perfect way to sum this up.
That's Alex Horosh from whistleout.com. You're listening to Spacetime. I'm Stuart Gary, and that's the show for now. You can subscribe and download Spacetime as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. Spacetime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more Spacetime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.